The first question is, a man on a cliff observes a boat at an angle of depression 30 degrees, which is approaching the shore to the point immediately beneath the observer with a uniform speed. 6 minutes later, the angle of depression of the boat is found to be 60 degrees. Find the time taken by the boat from here to reach the shore. Here the question is clear. In applications of trigonometry, we should be able to draw the diagram properly. That is the 60% of the solution. If we are able to draw the diagram properly, then our question will be done. Remaining part is calculation. That you will do definitely. Okay? Let's see. A man on a cliff. What do you mean by cliff? A steep rock. We read it in geography. A steep rock at the shore. So that is called a cliff. That let it be a cliff. Shore is, this is shore. Okay. A man on a cliff. A man is here on a cliff. Observes a boat at an angle of depression. This is shore. Here some, at this point boat is there. Observes a boat at an angle of depression 30 degrees. So angle of depression is 30 degrees. Immediately beneath the observer with a uniform speed. Here, uniform speed, it is approaching the shore like this. The angle of depression of the boat is found to be 60 degrees. 6 minutes later. 6 minutes later means first time he saw the boat here. Let it be A, B, C. First time he saw the boat here at the point C. 6 minutes later, it is approaching towards the shore. So it is coming in this way. 6 minutes later, let it be here. This is D. The angle of depression found to be 60 degrees. So this angle is 60 degrees, angle of depression. Okay. If this is 30, this becomes 30. Alternate interior angles are equal. These two lines are parallel. This is transversal, AC. Now take AD is transversal. If this is 60, this will become 60. Okay, right. Now solve the question. The time taken to travel from C to D is 6 minutes. Here, the boat is traveling with a uniform speed. So let the speed be x. Speed of the boat. X. Here it is given in minutes, so meters per minute. Here we have to find the distance of CD and BD. Then only we can solve. Merely knowing the time we cannot solve this question. If I take two triangles here, ABD and ABC, AB is common. By using this commonality, we can solve this question easily. So how do we find? We can take this is, if I take 60 degrees angle, this is opposite and this is adjacent. If I take 30 degrees angle, this is opposite and this is adjacent. So we can take tan trigonometric ratio. First let us find the distances of CD and BD. So the distance traveled from C to D is, so here we should know the distance formula. Distance is equal to speed into time. What is the speed here? X speed. Time is 6. So it becomes 6 meters. Now find the distance of BD. BD equal to, the speed is x and time is, we don't know, that is t. So x into t. So now we got CD and BD. So by using these measurements we can solve this question. Let's see. Take triangle ABD. Triangle ABD. In this triangle ABD we can take tan trigonometric ratio tan 60 equivalent to AB by BD. AB by BD. Tan 60 is root 3 equivalent to AB, we don't know, BD is xt. So now AB equal to root 3 xt. We got AB here. By using this triangle ABC, again we should get AB. Triangle ABC. In this triangle also we can take tan 30 degrees equal to AB by BC. Tan 30 is 1 by root 3 equal to AB by BC means this CD plus BD. CD is 6x, BD is xt. So 6x plus xt. 1 by root 3 equal to AB by, we can take x common here, x into 6 plus t. Now AB equal to, cross multiply, x into 6 plus t by root 3. This is again AB. By using these two ABs, we can equate them. Root 3x. Let it be equation 1 and equation 2. From equation 1 and 2, AB equal to AB. So root 3 xt equal to x into 6 plus t by root 3. This x and this x will be cancelled. Root 3, when it comes to this side, this becomes multiplication. So root 3 into root 3, 3. 3 into t, 3t equal to 6 plus t. T comes to this side. 3t minus t, 2t equal to 6. Then t equal to 2 ones, 2 threes, 3. So t is 3 minutes. So what we have to find here? Find the time taken by the boat from here to reach the shore. So that we got. So find time taken by the boat to reach the shore is 3 minutes. That's it. Yeah, let's see this question. A straight highway leads to the foot of the tower. A straight highway is there that is leading to the foot of the tower. A man standing on the top of the 75 meters high observes two cars at angles of depression 30 degrees and 60 degrees, which are approaching the foot of the tower. If one car is exactly behind the other on the same side of the tower, find the distance between the two cars. This is 2023 question. We have to use root 3 equal to 1.73. It is given in the question. Drawing the proper diagram for the given information means 60% of the question will be solved. The remaining 40% is calculation. That's it. A straight highway leads to the foot of the tower. One tower is there like this. Let it be tower. Okay. This is AB. Tower is AB. A straight highway leads to the foot of the tower. This is a highway. BC is a highway. Okay. A man standing on the top of 75 meters high. So a man is here at point A. the distance is 75 meters. Clear? Right. Observes two cars at an angles of depression of 30 degrees and 60 degrees. Angle of depression. So a man is here standing. So he is observing one car this is 30 degrees and another car at point D. So he is observing this car at an angle of depression 60 degrees. So these two lines are parallel. So it is 30, then it becomes 30. Alternate interior angles property. If this is 60, this becomes 60. So we have got two triangles here, ABD and ABC. By using this information, we can solve this question. Like in the previous question, this AB is common for both the triangles ABD and ABC. So by using this commonality, we can solve this question. Most of the questions can be solved by using the commonality in applications of trigonometry. Okay, please remember that one. So first write the given information. Height of the tower is equal to, that is AB equal to 75 meters. Now take the triangle ABD. Triangle ABD. In this triangle, we can take a tan ratio, tan 60 degrees equivalent to AB by BD. AB by BD. So here tan 60 is root 3 equal to AB 75 by BD. Now cross multiply. BD equal to 75 by root 3. Whenever you see the irrational number in the denominator, just rationalize that one. That means, how do we rationalize? By multiplying by root 3 and by dividing by root 3. So 75 into root 3, this becomes 75 root 3. Root 3 into root 3, it becomes 3, which is a rational number. Now cancel it. 3 ones, 3, 25s. So this is 25 root 3 meters. We got BD, which is 25 root 3. The thing what we have to find is, find the distance between the two cars. Here car 1 is there, here car 2 is there. So we have to find the distance of CD. Take the triangle ABC. In triangle ABC, again we can take tan 30 equal to opposite by adjacent. So AB by BC. AB by BC. Tan 30 is 1 by root 3 equal to AB 75 by BC. Now cross multiply. BC equal to 75 root 3. Okay, right. This is BC. So what we need? CD. How do we get CD? BC minus BD. CD equal to, that is distance between two cars. CD equal to total BC minus this part BD. BC minus BD. What is BC here? 75 root 3 minus BD is 25 root 3. Both are like terms. So 75 minus 25, that is 50 root 3. So here root 3 value is given 1.73. So we have to substitute. Now multiply. 5 3s 15. 5 7s 35 plus 1 36. 5 1s 5. 5 plus 3 8. Here 0. Now we have to put the 0 here. So 86.5 meters. So now the distance between the two cars is 86.5 meters. That's it. Let's see this question. From the top of a 7-meter high building, the angle of elevation of the top of the cable tower is 60 degrees and the angle of depression of its foot is 30 degrees. Determine the height of the tower. Here, one building is there and cable tower is there. This is the building which is 7 meters high. Let it be AB. Here tower is there. This is the ground. Angle of elevation of the top of the cable tower is 60. From the top of a building. From the top of a building to the top of the tower. So this is 60 degrees. From the top of the building to the top of the tower. That is 60 degrees angle of elevation. Now, from this top of the building to the foot of the tower, that means this is angle of depression is 30 degrees. If it is 30, this becomes 30. Because these two lines are parallel, this is transversal, alternate interior angles are equal. Okay? If this is 7, AB is 7, this also becomes 7. Let it be CD. This is E. Now the height of the cable tower is CE. Let it be H. Now this becomes H minus 7. Write the given information. Height of the building. Height of the building is AB, that equal to 7 meters. First let us see the approach. Here 7 meters is given, here also 7 meters. Now we have to find H, that is this part we have to find. If we are able to find this part, that is ED, then we can add this ED to CD, then we will get CE. So how do we find? By using this triangle, we can find this side. So if we get this side, this is equal to this side. So now we can use tan 60 trigonometric ratio, we can solve this one. So after solving this, we will add this measurement and this measurement, we will get the height of the tower. That's it. That is the approach. Now let's solve. First we have to find BC. How do we find BC? By taking triangle ABC. In triangle ABC, tan 30 equal to opposite by adjacent AB by BC. Tan 30 value is 1 by root 3 equal to AB 7 by BC. So now BC cross multiply. BC equal to 7 root 3 meters. I got BC. If it is 7 root 3, this is also 7 root 3. Now find ED. To find ED, we have to take triangle ADE. ADE. Tan 60 equal to, why we are taking tan 60? Because this is opposite and this is adjacent. H minus ED by AD. Tan 60 is root 3 equal to ED is H minus 7 by AD is 7 root 3. Multiply these two. 7 into 3 equal to H minus 7. 21 equal to H minus 7. Now H is equal to 21 plus 7, 28 meters. Now height of the tower H, that is 28 meters. That's it. Let's see this question. A ladder set against a wall at angle 45 degrees to the ground. If the foot of the ladder is pulled away from the wall through a distance of 4 meters, its top slides a distance 3 meters down the wall, making an angle 30 degrees with the ground. Find the final height of the ladder from the ground and the length of the ladder. Okay, let's see. So this is very interesting question. One ladder is there, so it is set against the wall. Let it be, this is a wall. So ladder, this is ground. Ladder is this one. This is ladder. So A, B, C. AC is ladder, AB is wall. So the angle is 45 degrees. So this is 45 degrees. Next point is, if the foot of the ladder is pulled away from the wall through a distance 4 meters, foot of the ladder, this is the foot of the ladder. If I pulled like this comes here on the ground. This foot of the ladder comes here. Now the point is, its top slides a distance 3 meters. This top slides a distance 3 meters. That means it comes here. This distance is 3 meters. So now the top of the ladder is here and the bottom of the ladder is here. Got it? Very carefully listen. Top slides a distance 3 meters. So this distance is 4 meters. This is D and this is E. So it is making an angle 30 degrees with the ground. This is making an angle 30 degrees. Find the final height of the ladder. So this height of the ladder we have to find, and the length of the ladder. So length of ladder, this one or this one we can find. Let the final height of the ladder from the ground be h. This is h. BE is h. BE equal to h meters. Let this distance be BC is x. BC is equal to x. CD is equal to 4 meters. Now the approach for the question is, this is h and this is 3 and this is 4 meters. Now take this triangle BED. In this triangle h is there, and take this triangle ABC. In this triangle also h is there. So by using this commonality we can solve this question. Take this triangle ABC. Take the triangle ABC. We can take tan 45. Tan 45 equal to opposite by adjacent. So opposite is AB by adjacent is BC. Tan 45 is 1. AB equal to AE plus BA. So H plus 3 by BC is X. So now X is equal to H plus 3. Now take this triangle EBD. Triangle DED. Tan 30 equal to BED means BED, this triangle. That means opposite by adjacent. BE by BD. Tan 30 is 1 by root 3 equal to BE is H by BD is X plus 4. Now find H here. H equal to X plus 4 by root 3. We got H here. What we need here? H we have to find. So take this H is equal to X, we got H plus 3. Substitute in this one. So X is H plus 3 plus 4 is there by root 3. So H is equal to H plus 7 by root 3. Now this is root 3H equal to H plus 7. Bring this H here. So if you take H common, root 3 minus 1 equal to 7. Now H is equal to 7 by root 3 minus 1. Root 3 value is 1.732. Now H is equal to 7 by 1.732 minus 1, that is 7 by 0.732. So if we simplify this one, we'll get 9.56 meters. So this is what we have to find, that is final height of the ladder. This is the final height of the ladder. Now the question is, we have to find this one, that is the length of the ladder. So length of the ladder is AC. If you take ABC triangle, if I take this triangle ABC, in this triangle this is the hypotenuse and this is the opposite. Which ratio I can take? Sine. So I am taking sine in ABC triangle. Triangle ABC, sine 45 equal to AB by AC. Sine 45 is 1 by root 2 equal to AB is H plus 3. H is 9.56 plus 3. 9.56 plus 3 by AC. 9.56, 9 plus 3, that is 12.56 by AC equal to 1 by root 2. Now cross multiply. AC equal to 12.56 into root 2. Root 2 value is 1.414 into 12.56. If we multiply this one, we get 17.76 meters. So this is length of the ladder. This is very interesting question. This is 2023 question.